Hi, everyone. Thanks for joining us for the next episode of Model Mondays. My name's Anna. I'm an event planner for Reactor, joining you from Redmond, Washington. Before we start, I do have some quick housekeeping. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience and presenters. While we absolutely encourage engagement in the chat, we ask that you please be mindful of your commentary, remain professional and on topic. Keep an eye on that chat. We'll be dropping helpful links and checking for questions for our presenters and hosts to answer live. Our session is being recorded and will be available to view on demand right here on the Microsoft Reactor channel. With that, I'd love to turn it over to our host for today. Thanks for joining.
Welcome, everyone, and thanks, Anna, for sharing the code of contact. So welcome to another episode of Model Mondays. I'm Carlotta Castelluccio. I'm an AI advocate at Microsoft, and I'll be your host for today's session. I'm joined from Italy, and I've seen a few of you in the chat already shared where they are joining from. So keep it coming. We want to know where are you joining from. We know we have a global audience, and that's great. So for those of you who joined the series for the first time, this series is going on throughout the whole summer for those of you who are in the Northern Hemisphere, so till late September. And we have a great lineup for you all to navigate the ever-evolving AI landscape. We have a packed agenda for today, as always, but keep your questions coming as we are going to reserve some Q&A time later. So this series also includes a weekly AMA, Ask Me Anything, where the guest of the Reactor episode, who is Sandeep Sen, as you can see from the spoiler here in the deck. So we host also a weekly AMA on the Azure AI Foundry Discord community, and you're going to get the link to join the community on the chat. Which, by the way, is a community where we don't just host these AMA, is a community where you can find peers building with Azure AI Foundry, agents, and more. And you can also ask questions for support, get some support from advocates from my team, sometimes people from the pro groups as well. So I really encourage you to join not only the AMA, but also use the Discord server as kind of a tool at your disposal to learn and grow in your journey with your AI learning journey. And keep an eye out for that one, for the AMA for Friday. Now, without further ado, let me introduce our guest for today. So I'll be joined by Sandeep Sen, and here he is. Sandeep Sen, he's a PM in the Azure MCP team, but he has a developer background, and he's going to show us some great hands-on stuff about the Azure MCP server later in the session. So Sandeep, do you want to quickly say hi, introduce a bit, what is your role, focus in the Azure MCP team right now in Microsoft?
Great. So hi, I'm Sandeep. I'm a PM on Azure MCP, and my role right now is to figure out how to make Azure MCP awesome. And with MCP, my team is also working on another product called GitHub Copilot for Azure. It's a Copilot agent which is currently present in VS Code and Visual Studio, and soon coming to other IDEs as well, like IntelliJ. Uh, so our goal is to make it a seamless experience from a specialized Azure agent on your development and supercharge it. And we are the toolbox for the front end, which is the GitHub Azure agent.
Thanks, Sandeep. Looks like you have some ambitious goals. You and your team have some ambitious goals,
Right.
And I know you are also very open to get feedback on
Right.
on the tools you're working on. So I encourage everyone here in the chat to to share with us if you already tried Azure MCP server, and if so, if you have any feedback you want to share with us. And again, Sandeep will be will be available on Friday as well for the AMA. So that's another opportunity you have to kind of share your feedback if you're going to test the MCP server, the Azure MCP server throughout the week. So today there's a huge interest around MCP and other open protocols in the agentic AI domain, and Microsoft is kind of pushing towards this direction, building MCP servers for different purposes. We have a Microsoft LearnDoc server as well. Microsoft is developing the C# SDK for MCP and also integrating this protocol in existing platform. So I wanted to hear your thoughts, Sandeep. Is this all hype, or is MCP kind of shaping the future of AI and development? What's your opinion on that?
I think it's not just hype anymore. Like any technology, it requires a critical mass. I think the critical mass has been achieved, and you'll see a lot of MCP servers. So the good thing about MCP is you can leverage your existing ways of communication to the service, let's say REST API or GraphQL or whatever, and expose it to the agents in a standardized format. So basically, you're leveraging whatever you already have. So that's why I mean, the MCP community in general has reached critical mass pretty fast, and it's pretty easy to develop as well. You can use even Copilot prompts to develop a wrapper over your existing tool and expose it through JSON RPC. So it's super, I wouldn't say super easy, it's less friction. And for any technology to progress, we need critical mass and a path to success. I think we have both of them here. And as you see, MCP is pretty much a standard spec now, and it has been adopted by even competitors. So originally, MCP was started by Anthropic, and now it's been adopted by even OpenAI. So even competitors are adopting it. So I think it's a good space to invest in, and that's why you'll see most of the cloud providers also have their MCP server, and any kind of tool you can think of has a MCP server, like Twilio, Slack, everything you can think of has a MCP server, which lets you communicate with other things. But being said that, I also want to say this is a new space, so there will be breaking changes throughout. And as you said, we love feedback. Please visit our repo. So based on your upvotes and on your feedback, we will definitely prioritize our next tools, because resources are limited. We have to run on a priority basis. So based on your inputs as users of these tools, we'll definitely prioritize the tools.
Thanks, Sandeep. That's a wonderful opportunity for you all to share your feedback. And we're going to share all the links you need, the links to the MCP server repo as well in a moment. I just wanted to say that Model Mondays is kind of designed to support you all in choosing the right model for your use case by keeping you informed about the latest and greatest, by showcasing tools that might be helpful to do comparative analysis between models, and by discussing how we can enhance the models to get better outcomes. So how MCP server kind of fit within this goal. Today's topic is kind of at the intersection of all this stuff I just mentioned, because the Azure MCP server enhances your model by providing it access to additional functionalities and data, but it also enables you to ask questions about models and get answers which are grounded on Azure official docs. Anything else you want to add, Sandeep, before we go into the hands-on part and actually see this in action?
No, let's see this in action right now.
Yeah. Perfect. Let's go with it.
Hello, everyone. I am Sandeep, and I am a product manager on Core AI, and I am currently working on Azure MCP server, which lets AI agents talk to Azure services. You might have questioned what is MCP, and you must have seen this picture everywhere of talking of MCP as a standardized way to connect to agents and services and whatnot. But let's dive a little bit deeper into it. and specifically work on what is Azure MCP server. Like as in the prior picture, Azure MCP server is a server which implements model context protocol. That's what MCP is. And as the picture suggested, model context protocol is kind of a standardization of message formats and a way to communicate between different services and an AI agents. So what actually Azure MCP is, we are trying to provide a standardized way to interact between various different Azure services and other Azure related MCP servers to any host AI agent. So what happens right now is AI agent, instead of calling your services directly or maybe some other servers directly through custom written APIs, it can directly leverage on Azure MCP server, and you can pretty much talk to any of your deployed resource or service on Azure and do much more. So model context protocol has three major types of primitives, tools, prompt, and resources. As of now, Azure MCP server only exposes tools. You can think of tools as in a lot of functionality or a typical kind of a operation you can do on a service. So Azure MCP server exposes all that for any agent to consume. So how does it actually work? So what we basically do is, whenever your agent asks any questions in natural language or something, Azure MCP server provides a list of tools, and based on that, that agent can decide what tool to invoke, and that tool then operates on a function and goes to a service and gets some results. So that's in a nutshell, very high level, what an Azure MCP server is. But let's dig deeper into it rather than just staying at a surface level. So what is this? Let's talk about this host AI agent. What kind of AI agent is it? So it's basically, you can think of it as a GitHub Copilot or maybe an IntelliJ AI chat, or even something else, even like the core agent in Cursor or Klein or something else. So that's what it is. But we do have an option of a Azure branded AI agent as well. And that is GitHub Copilot for Azure. If you use this Copilot for Azure, you get certain things extra. You have custom Azure modes, you have better prompts. We also hook in this GitHub Copilot for Azure to other Azure extensions, so it has more data to perform tasks and more data coming from your Azure subscription. And it has access to other extension UI agents as well. So this is a special agent, if you may say, and which is close to our heart. So let's talk about a typical flow. So what happens is, let's say you are a user, you are using this Copilot agent, you log in. Your login tokens and credentials will be then, not credentials, your login token will be then used to authenticate across Azure services. So if you have access to certain services, your agent and MCP server will have access to those services. If not, then you'll not have access to those services. And that's done for basic security purposes. So let's say you ask, hey, show me everything in my account. So what happens is that you type this on your agent, and your agent then queries the MCP server and asks, hey, what tool do you have? What tool should I fire? And then let's say it found a tool listing everything in your resource tool or resource group tool. And then it will show you this is the tool I'm going to fire. If you say continue or say then, the Azure MCP server will use Azure identity underneath, Azure SDK's identity module underneath, get the authentication done, and then it will use the Azure SDK's REST APIs or whatever protocol it uses to connect to the Azure service, get the data you requested for, get it back and pass it on to the host, and then the host will format all this and show you in a very formatted way. Now, Azure MCP server can not only call Azure services, but it can also call other MCP servers. One of our biggest remote servers right now is the MS Learn server. Now, Azure MCP server can call that too. It can also invoke command line tools like Azure CLI or Azure Developer CLI, also known as AZD. And it can do much more. And all that power of a simple standard format is passed along to the agent. And of course, if you use GitHub Copilot for Azure agent, your power is multiplied because it is aware of your Azure context as well. So enough talking about these things. Now let's look at how it works on actually VS Code, right? So this is my VS Code. Now the first question is, how do I get the Copilot and agent? I would say just go to this repo and we have install instructions here, or even better, you can go to Visual Studio Code extensions marketplace and look for, say, Azure MCP, and here is our Azure MCP server, or maybe you want to start with GitHub Copilot for Azure, so GitHub Copilot for Azure, and you can go and one click install all that. And obviously I have already installed all this, and we'll talk later about how to install it in other places like IntelliJ or Visual Studio, where we are coming soon. And let's get back to our Visual Studio Code. So we are back to our Visual Studio Code. Since these extensions are installed already, maybe not bicep. So I have Azure MCP server and I have GitHub Copilot for Azure somewhere here. Yeah, here it is. So when I click on this chat, so first thing I need to do is figure out what are the tools available. These are the tools available here. And some of them are selected, some of them are not selected. Currently, Visual Studio Code has a limit of 128 tools, so that it is very snappy and performs really well. And a lot of times you'll also see that, hey, I might have the MCP server, but the MCP server is not active. So all you need to do is go to command palette, go to MCP list server and see which one is running. You can actually stop the server also, but then it won't be able to answer stuff. So it's simply like clicking on here, you can stop, start and show output. Maybe let's say I just did a show output. So there is one tool in Microsoft Docs, and Azure MCP server has 32 tools in namespaces, and you can just basically verify what's going on here. So what I did for this was I downloaded Get Started with AI Agents template from Azure Samples. It's also available as a AZD template, and I deployed that as well. So I deployed that, but I forgot where did I deploy it. So I can ask what resource to have I let's see what it does. It found one reference, it will check, and yeah, let's say instead of doing continue for everything, I'm going to say allow for this session. So it will run all the commands. Now, please be careful if you are running a write command, let's say deploying something or deleting something, and you just click on it, maybe it will get some nasty results. But here, I know I'm not going to do a delete operation, so I'm good here. So it said, hey, your resource group is RGMM demo, and it got it from AZD. And this is the subscription ID, this is the location and whatnot. So I want to see, are there any AI Foundry models in this? So let me check. Not shouting at it. If I can type. So let's see. Let's see what tool it will pick. It is trying to pick the Foundry tool. And again, by a session, we mean the question is the session. So you see I have to click continue again. So if I do it for this session again, it will not ask me for any other questions in this session. So there is a clear distinction there. If I do it allow for this workspace, it's never going to ask me for this permission in this workspace. So then the question doesn't mean. So yeah, it says I have deployed GPT or mini and whatnot here. What else is there in this RG? Let's try RG. Let's see if it knows RG means resource group, but that's more of a LLM thing. So yeah, it knows and it's running this command. And now it didn't ask me for permission because I allowed it for this workspace. And it ran the tool. And the tool it ran is Azure CLI. It didn't run AZD this time, but the first time it ran AZD. So these are the details, and of course, please be super careful while running these. Like if you have permission to get these things, and if you are the security officer on, let's say, Key Vault, your secrets will be dumped out here. So be careful. There is an error. So the external server for some reason shut down. Let's start it again. And we have error handling here. So that is something what these are the things you can do. These are simple scenarios where you are just asking it question about your resources or what are the status of your things and how is your deployment done. But there are more complex scenarios also you can do about the using this, and especially with GitHub Copilot for Azure Agent. Let's dive into those. So we were here, let's say I want to, what is the best model I can use for this project? And this is something I haven't run myself as well, so I do not know what's going to be the answer. So it's running a best practice tool, which is also a tool. And let's say allow in this workspace. Yeah. So now it's doing a Microsoft Docs search. Remember, Microsoft Docs is a remote MCP server. Okay, it's doing a lot of best practices and it's doing 4.0 mini, but yeah. Let's say I'm still not happy. I want 4.0. Change my deployed model and bicep code to use GPT 4.0. Now, definitely I'm not going to deploy it because it will take a lot of time. But in the meanwhile, it's making the code changes and whatnot. Let's look into, do you guys remember it showed me a list of things that were there? And okay, so it made the changes I can accept or undo and deploy and whatnot. And I can also say things like, hey, there was an error. Please fix this error for me or whatnot. So yeah, I'm not going to provision, but remember at first we said what was deployed and what not. Let's check, are these accurate or not? So let me go to my thing and it is there. So let's figure out one of the things. What was deployed? And so yeah, so it says something with ending with PNG is the container registry and something ending with PNG is the container registry. So it is getting me accurate data. And based on that, it is also making these changes. Now, I'm not going to do AZD provisioning and whatnot, and I'm going to cancel and I'm going to undo, but you get the idea what you can do with this thing. And this is a very short example I'm giving. I have my co-worker Chris Harris. He is much better at GitHub Copilot for Azure than me, and he is building an app just basically vibe coding on this. Maybe he'll show it to you guys someday. With that, I think the demo is pretty much over. Let's look at the distribution mediums. So how to get this? That's the important thing. So one, you can come to this repo and get this. While you're here, do look at these Azure MCP commands. It's under docs. It'll show you what kind of commands we have. You can use it directly through CLI as well. You don't need an agent. But again, agent does a lot of good work for you. You can get it from Visual Studio Code here. Soon we'll add it to Visual Studio Marketplace as well. Just stay tuned for it. Maybe in a week or so, it will be in Visual Studio Marketplace. Other ways to install it. You can just scroll down that page, look at manual install. We distribute through NPM. So if you use NPM execute or npx, you can install that server directly. It comes in. And then pretty much every IDE has a MCP JSON. You can put in these things under server and it's going to work. IntelliJ has a AI extension path wherein you can put this JSON and just copy and paste, it will start working. Same for pretty much every other VS Code based IDE. Talking about IntelliJ, we are coming soon to IntelliJ in about 2 to 3 weeks. We'll be part of, let me check, IntelliJ plugin, which one? IntelliJ plugin, Azure Toolkit. So we will be part of this guy. We will be part of Azure Toolkit for IntelliJ. When you look at the next version beyond 3.95, we'll be part of that, and it will check if you have any of the AI agents installed. We will download this package for you automatically and do all this kind of configuration, and it will be auto install or a one-click install. So we'll be there in IntelliJ as well. What else? We are in Klein Marketplace. If you use Klein, we are there. Just download it from there. What else? There is a MCP registry for Azure as well. It's called mcp.azure.com. You'll find us here. You can click here and install it here. You'll see more buttons pretty soon. And you can click and install from here. And we are in mcp.so registry. And most importantly, if you don't like any of that, we are in Docker Hub as well. Download our Docker container and do stuff with it. Yeah. And before we go, there are a lot of new things coming up. Stay tuned. And I'd like to request you to come to our GitHub repository, open issues. Please do let us know what kind of workflows you're working on, and we would love to include those tools and package and distribute as soon as possible. And fun fact, this is a beta. This will go GA and stable before the end of October. So before GitHub Universe will be stable, start using it on your production. Thank you.
Huge thanks, Sandeep. That was very interesting, and I'm looking forward to test it myself. We've got a couple of questions from the chat, and I think you definitely answered Donald's question already, who was asking what is MCP, and it's my bad. We are so used to acronyms that I didn't explain. Right. It is Model Context Protocol. So I would go to the question from Gaurav. I'm so sorry if I'm mispronouncing your name. So the question is, how does authentication works between agent and the Azure MCP server?
So again, so the agent and Azure MCP server pretty much run on the same context. So basically, the agent uses your, so agent has a different auth, and it will send it, and the MCP server has a different auth, and agent just asks a question for locally installed MCP servers, it's through standard IO, and it will ask a question, and MCP server is the important auth that will authenticate you separately for Azure, it will be Azure Enter ID, and it will authenticate you to the services. And agent itself, if it requires you to directly connect to Azure, for most of the purposes it does not, then it has to go through a separate authentication.
Thank you so much, Sandeep. And there's a follow-up question. So Azure MCP servers makes use of private endpoints to allow connectivity from agent on Azure private network?
We haven't tested it on private endpoints. We are all looking at public stuff. So anything in your subscription, pretty much we think it should work. But private endpoint is something, if we get enough upvotes, we'll test it and certify it. So it should work. We haven't tested on that.
Thank you. And with that, I think we answered all the questions in the chat. As I said, we are going to have an AMA on Friday, so keep coming your questions, bring your questions at the table as well. Huge thanks, Sandeep, for being with us today and for the hands-on demo, and see you on Friday.
Yeah, thank you.
So next, we have our customer story. So if you watched the last week episode, we kind of started this customer story segment because we really wanted to tell the two parts of the story. From one hand, people developing the products, from the other hand, people using the products in real life and bringing it to real life. So for this week, we have already our guest here. So we have Kurt DeMaagd from Side Machine. So hi, Kurt, how are you doing? Do you want to quickly introduce yourself and your company? I think you're muted.
How about this?
Okay.
Thank you. I'm Kurt DeMaagd from Site Machine, Chief AI Officer, and at Site Machine we do AI data management for manufacturing. And so the demonstration we have here today is about doing some manufacturing optimization for beverage manufacturers.
Wonderful. Thanks, Kurt. So without further ado, I would say let's look at, again, some hands-on stuff, the demo you prepared for us today. And then again, if you have any questions for Kurt, feel free to post them in the chat, and we're going to answer to the questions later on. Thank you.
Hi, I'm Kurt DeMaagd, Chief AI Officer at Site Machine, and I'm excited to tell you a little bit about our Filler AI agent. Let's start by looking at the use case. Site Machine is a platform for manufacturing data and AI. So what that means is we work on the manufacturing plant floor, gathering data, getting it into an AI-ready data format, and providing the tools to help engineers, supervisors, operators make that data useful. A lot of the work that we've been doing recently has been in the food and beverage manufacturing space. And so think of, for example, you might even have a can or a glass of soda, maybe beer, maybe a juice, water, etc., sitting right next to you. So the production process of getting that from a large tank somewhere into the can or bottle is done on your filling line. And as the names might imply, the filler is one of the most important assets on that particular production line. So this is a high-speed machine, looks like a giant carousel basically with cans or bottles in it that are being filled up, and runs, as I said, at very high speed. For cans, you're often talking well into the thousands of cans per minute. Bottles can be, many hundreds of bottles per minute. And it's a fairly, complex type of process where you're, of course, filling the liquid into the can or bottle, potentially adding gases. You have to get it sealed off, et cetera, all at very high speeds. And so this is a fairly expensive, complex asset that ends up being the bottleneck in your production process. And now, when we talk about a filler agent here, I should also point out we don't want to just optimize the filler. So, for example, if the packaging machine is running too slow, if it can't keep up with the number of bottles or number of cans that the filler agent is producing, well, then the filler has to slow down and might not be running at its optimal speed. And so we need to make sure that we're also optimizing across the entire manufacturing line, not simply at a single asset. And so that's part of what this filler agent is going to help us with doing. It's going to provide suggestions to the engineers, the supervisors, the operators on real time, how they could be improving their process, or also doing things like retrospective analysis of root cause, what happened yesterday, or forward-looking if they're thinking about changing set points, how they could potentially improve that process tomorrow. So it's a fairly diverse tool to help manufacturing users. It's something that can be accessed through a variety of different methods. So, through our Site Machine data platform, you would be able to go through a Copilot natural language type of interface and ask questions, all the way over to things like a 3D visualization. We work with NVIDIA's Omniverse to create a digital twin, which provides that richer sort of visualization tool of the recommendations. But before I get ahead of myself, let's briefly look at the architecture we use, and then we'll take a look at the demo itself. So basic architecture here. On the left-hand side, of course, we have those different user interfaces I mentioned, things like the Site Machine UI or an Omniverse digital twin. That flows through over to a web app, which acts as basically an API endpoint. And then finally, we get to the real meat of the agent here. So, of course, we have an orchestrator. We've got that language model, which is doing the basic intent analysis, understanding what the user wants us to do, break that down into a series of components that get farmed off to the different tools, reassembles those answers, and reports back to the end user. So with our orchestration, we've actually done two different language models in here, depending on the IT use cases. For example, whether or not we need sort of local processing versus access to the cloud, as we work with GPT-4.1, and Llama actually has also worked here. From there, we then have our set of tools. As a quite sort of a side note here on the tools, it's quite interesting how merely giving a language model a list of tools that it can work with helps put guardrails on how it's going to answer questions. And so if you were to take a question like, how was my manufacturing process affected yesterday because of this particular flavor and these environmental conditions, and just ask that over to ChatGPT. Now, of course, it doesn't have the data necessary, but if you ask it 3 times, it'll give you 3 completely different answers, and all of them could be a little bit debatable whether they're useful. But if you give it even just a list of tools, it will use those as the foundation for how it wants to answer the questions. And so already just having that in place helps guide the question. Now, the tools that we use in our case, first of all, we have a name management tool. This is another language model. It's actually fine-tuned off of 535, which is used to help us translate between the jargon and ways of expressing questions that we found from manufacturing users into a little bit more of a data science jargoning that we will need for doing analytics for the agent itself. So we have that name management tool, which is calling over to our factory namespace manager, which is doing those translations for us. We have our data manager, which calls over to Site Machine, the main data platform, in order to get the data that's going to be used for the analytics. And what I will say as a brief side note here, we don't actually pass back and forth full data payloads. We just pass back and forth a file name for a temporary data file. We did play around with passing the full data payloads. Of course, that makes things a lot slower, which of course means it's going to be a lot more expensive. And for some reason, the language models periodically would just change part of the data payload. So we didn't want that to happen. So the data manager is actually only passing around temporary file names, which can then be used by other tools. It doesn't pass around actual data. And then finally, we have our analytics tools that we've made available to the agent. And we have a variety of different tools for anomaly detection, prediction, optimization, et cetera. And these can work off of both some auto ML, automatically trained algorithms that we can create for it, or in many cases, we actually work off of pre-trained machine learning models, which have already been validated, which help to ensure the quality and accuracy of our results. So anyway, enough of me babbling. Let's go over and take a look at how this works. Okay, so what you're looking at now is this visualization of the bottling line. And this is, as I mentioned, developed with NVIDIA's Omniverse, and it is a 3D tool that you can move around with, and that way can provide real-time visual cues to the manufacturing team. In fact, as I'm talking here, you may have already seen some of these little bubbles, switch colors, change values, etc. And so what we're seeing here, of course, is the bottling line. We're able to then push recommendations because this is sitting on top of a real-time data feed, which has the suggestions coming in. And so this is the sort of first level where you can get sort of interesting updates on key processing parameters, which may be affecting the overall performance of the line. And we don't want to just have that. We also want to be able to give suggestions of how to respond to some of these problems, or how to optimize production in general. So even if things are doing sort of okay, can we actually achieve better performance? And so you have options like, if we go down here, this purple thing, ways to optimize, these are recommendations that are coming from the agent based on monitoring that real-time data stream and giving some information to the operator. And so we can actually take that and you can kind of go through, and it will zoom in over to where you need to potentially make the change and give you some additional information on what you might want to change at that point. And of course, you kind of zoom around the line this way, zoom to different points in the line, all with different suggestions. And so it's sort of a neat little tool. And by sort of combining the AI agent recommendations with this 3D visualization really helps to take these sort of abstract optimization concepts and make them very real to the operators. Also, very briefly, hop over to our chat-based interface here. So we do have a Copilot interface. You can embed it right inside of, say, your daily meeting dashboard. Ask some questions about what was happening yesterday, maybe what you might want to do today. For the sake of demo time, I have this version pre-filled out here where they were asking what the chance of downtime would have been yesterday if the temperature were 45 degrees. And it, okay, that was a silly question. It was running very well at that time. The temperature would not have, that temperature would not have affected it. But you can see that's sort of a tool for playing with what if analysis, where the engineer, the supervisor, does not need to be a data scientist to go out and perform the analysis. It's all right there for them. So with that, I will just say thank you for your time and attention, and look forward to if anyone has questions on what we've done, what's worked well, and where we hope to take this in the future. So thank you for your time.
Thank you so much, Kurt. This was very fascinating. And we got a question from Nitya, which I'm also curious about hearing the answer. So how did you select the different models for each agent, the orchestrator, the translator, etc.? And are there any reasoning agents, reasoning models involved in the system?
Yeah, very good question. Part of it was just very pragmatic, especially when working in the manufacturing space. There is a fair bit of jargon where there are words that we would use just as an average person, like performance, that actually has a very specific definition in manufacturing. And so what we were looking for in many cases was which sort of models actually gave us the best, I'm going to say pro, in terms of having some knowledge that we could build off of, but nonetheless that we could fine tune and train a little bit to build on top of, either through fine tuning, for example, with the namespace manager, or through prompt management or prompt engineering through the main orchestrator, to sort of override and make sure that it was speaking manufacturing instead of speaking English. And so we spent a lot of time doing that. It was sort of a trial and error, to be honest. I wish I could say I had developed this great academic architecture for how we did it. Much more of it was just what seemed to be working, what wasn't working. In terms of actual reasoning, we haven't done a whole lot with reasoning models in here yet. So far, we've sort of brought our own reasoning to bear with the tools, and once we've given it those tools, just the more traditional, like a GPT-4.1 did a fine job of picking out which tools and assembling things together. And that's mostly because of the sort of extreme paranoia where we're trying to control the reasoning a lot, because the cost of an error on a manufacturing process is so high. So we do put very tight guardrails on what's working.
Thanks, Kurt. So look, it looks like a lot of work. Congrats for the result you have achieved so far. And thank you so much for the time you spent with us today. Much appreciated.
Yeah, thank you for having me.
Of course. So we have already our next thing on the screen, which is the next episode of Model Mondays that will be hosted by Nitya. You might be familiar with Nitya already. She hosted lots of, she's kind of the mind behind Model Mondays, and she hosted lots of sessions already. And we have another guest, of course, from Microsoft, program manager from the Core AI team, Manav Dalala. So they are going to chat about on-device and local AI. So make sure to tune in next week for the next episode of Model Mondays. And then as we wrap up, I also have some other things to remind you. For example, on this Friday at 1:30 p.m. Eastern Time, we're going to have the AMA with Sandep. So make sure to join the Discord server community and join the AMA. And then here you can find some other useful resources. First of all, this QR code and this link where you can look at the whole Model Monday schedule. Here is the direct QR code for the AMA on Friday. And here you can find our developer forum on GitHub. So another digital community we have on GitHub, where we also do some kind of, we post some kind of summaries of and highlights of the Model Mondays episode there. And I'm sharing all these links and QR codes, but no worries, we are going to also share with you. So a PDF version of this deck will be available for you as well. No rush to kind of getting all the links here. What else we have? As I promised, we are you have here the link to the Azure MCP GitHub repo. So as Sandeep also said, we encourage you to test it and provide feedback. Then here's also the link and the QR code to the documentation of the Azure MCP server, and the link and the QR code to the Visual Studio Code extension. And finally, a few other links that again will be included in the final PDF deck to download the Azure MCP server for Docker from MCR, the Microsoft Container Registry. And as Sandeep mentioned, coming soon, we are going to have the Azure MCP server in IntelliJ as well. So keep an eye out for that as well. And with that, here's the same links that I've showcased to you in a different format. But with that, I would say we can wrap up this Model Mondays episode. So see you on Friday for the AMA, and then next week for the coming episode. Thank you so much, everyone, for joining us today, for answering questions, commenting on the chat, and see you soon. Thank you. Bye bye.
Thank you all for joining, and thank you to our speakers. This session is a part of a series. To register for future shows and watch past episodes on demand, you can follow the link on the screen or in the chat. We're always looking to improve our sessions and your experience. If you have any feedback for us, we would love to hear what you have to say. You can find that link on the screen or in the chat. We'll see you at the next one.